Hello again. This time another SALT question from MRSM paper. Okay, let's look at what this question talks about. It says that a colorless solution, okay, it's a colorless solution. So it's can't be Cu2 plus, it can't be Fe2 plus, and it can't be Fe3 plus. Alright. It contains one cation and two anions. Okay, so look at test 1. Alright, test 1, vapor produced turns damp red litmus paper to blue. So that means it must have alkaline properties lah. Okay, the vapor, the gas has alkaline properties. Okay, second test, brown ring. Okay, brown ring, straight away you must know. Brown ring, it means it has nitrate ion. Okay, and this one, it uses what? It uses nitric acid. Okay, nitric acid and also silver nitrate. Alright, so silver nitrate. Okay, so let's look at this one. So you can see, okay, so brown ring, yes, brown ring is nitrate ion, and then nitric acid and also silver nitrate. So it contains chloride ion. Alright, okay, let's go back to page. Alright, so this one contains chloride ion. Okay, so they ask you to write the appropriate inferences. Inferences means why. Okay, why is the observation like that? Okay, explain why is the observation like that. Okay, what does it contain? So you can say for test 1. Okay, for test 1, all right. The inference is that the gas produced, okay, contains maybe you can say the gas produced has alkaline properties. Okay, then you can say test 2, nitrate ion, okay, is present right, because it has brown ring form. Okay, and then test 3, what is present? Chloride ion is present. Okay, chloride ion is present. Chloride ion is present. Okay, because of the white precipitate form. Okay, why is it that there is white precipitate when there is chloride? Because this AgNO3, okay, will react with the chloride ion. Okay, when AgNO3 react with the chloride ion, what will happen is it becomes AgCl. AgCl is a white precipitate. Okay, we learned that all chlorides are soluble except for Pa. Okay, PbCl, AgCl, and also HgCl. So we know this AgCl is the white precipitate. All chlorides are soluble except for Pa. You can see it in this. Yes, this is the one. Okay, so all chlorides are soluble except for Pb, Ag, and Hg. Okay, Hg2Cl2. So this is the AgCl, the white precipitate. Okay, let's get back. Next page now. Write the ionic equation for test 3. So test 3 is the AgCl. AgCl. Okay, so shortcut, write your Ag ion. Okay, and then write the Cl negative ion. So this is the precipitate. Okay, I'll show you the question again. Test 3, test 3 is this one. So how did it become the AgCl? Alright, how did it become the AgCl? From the Ag ion and the Cl ion. Ag plus ion and Cl negative ion, AgCl. Okay, second one. Wants to prepare pure crystalline zinc sulfate. Okay, wants to prepare zinc sulfate. So it wants to prepare zinc sulfate. Every time you see anything to do with salt, write the equation first, then you can answer many questions. So you, by reacting dilute sulfuric acid, okay, with a substance X. Alright, so with a substance X. So we don't know what is the substance X. So first of all, you got to ask yourself, this zinc sulfate, is zinc sulfate soluble or not? All sulfates are soluble except for persatuan bahasa Cina. Is this persatuan bahasa Cina? No, it's not. So all sulfates are soluble. So this is soluble except for persatuan bahasa Cina. Okay, so for soluble, there are two methods for preparation. Okay, so you got to ask yourself, is this let's turn to the page. Let's see. So for soluble salt, there are two methods. Okay, for ammonium salt, okay, ammonium salt is NH4+. For sodium salts, Na+, and for potassium salts, what we must do is we must do neutralization, okay, using the titration method. Okay, whereas if it's not ammonium salt, not sodium salt, not potassium salt, then we use either an acid with a reactive metal, or we use an acid with metal oxide, or we use acid with metal carbonate. So ask yourself, zinc sulfate. Okay, we want to prepare zinc sulfate, right? Check. Okay, this one. We want to prepare zinc sulfate, right? It's soluble, so we've got two methods. Then ask yourself, is it potassium, sodium, ammonium or not? It's not. So we cannot use method 1. We cannot use titration method. So we must use method 2 lah. Okay, method 2 is what? Method 2, we must use acid with reactive metal, acid with metal oxide, or acid with metal carbonate. Okay, so what can we use? We already know the acid. We already know we are using sulfuric acid. Okay, so we want to okay, so we already know this is the acid. So you can either use we already have the sulfate. Okay, we already have the sulfate, which is this part. Then we need this part. So we can use acid with reactive metal, which is zinc, or acid with metal oxide, or we can use acid with metal carbonate. Okay, those three that is in your textbook. So name the substance X. So any of these, and don't forget it's a name. So you can either write zinc or zinc oxide or zinc carbonate. Okay, just double check. Is zinc more electropositive than H or not? Yes, it is. Okay, in the electrochemical series, okay, kalau nak cari makanan ada zat besi, besi is iron, selalu pergi hutan curi ayam. Okay, H is here, zinc is here. So zinc is more electropositive than H. Okay, the higher the metal is, the more electropositive it is. So zinc is more electropositive than H. So yes, zinc can displace H from H2SO4. So yes, zinc can be used. Okay, but in other questions, if they ask you to prepare copper 2 sulfate, let's say, then you cannot use copper because copper is at the bottom of H. So copper cannot displace the H. Copper is less electropositive than H. Okay, that would be another question if they ask you to prepare copper 2 sulfate. Anyway, it is zinc, so write the equation. So if you have written zinc, then you can say H2SO4, okay, plus zinc, okay, zinc sulfate and H2. If you have written zinc oxide, then you have to write H2SO4 plus zinc oxide. So you change partner, you get zinc sulfate and water. Okay, if you have used the third one, zinc carbonate, then you have to write acid plus zinc carbonate, okay, to give you change partner zinc sulfate, and from carbonate you get carbon dioxide, and from the H and O you have water. Okay, alright, next question. Calculate maximum mass of zinc sulfate that can be prepared. Okay, so this one depends on which equation you use. Okay, let's say I use that can be prepared. Okay, sorry. Let me erase this. Okay, so we have H2SO4. Okay, let's say I use the first equation and I will get zinc sulfate. Now, what is the maximum mass that can be prepared if sulfuric acid? Okay, so this one is if I use mole per dm cube, that's M, molarity. 0.2 mole per dm cube, and 50 cm cube, that is volume, 50 cm cube. Okay, so I'm only interested in this and this. Now this is the answer that I want to look for. Okay, and this is the numbers that is given. Alright, so I can find number of mole from there. Okay, this is the 3-step calculation. Now I've taught you before 3-step calculation. Number of mole of H2SO4, you get it from the information given there. We use this formula, mv over 1000. Okay, so this is 0.2 times 50 divided by 1000. Let's calculate and see. 0.2 times 50 divided by 1000. Okay, so this is 0.01 mole. Okay, this is the first step. Second step is to compare ratio. So from the equation we can see 1 mole of H2SO4 ratio will produce 1 mole of zinc sulfate. So from the experiment now we only use 0.01 mole of H2SO4. Okay, so the amount of zinc sulfate that is produced will also be 0.01 zinc sulfate. Okay, that's step number 2. And step number 3, now we know that zinc sulfate, okay, that is produced is 0.01 mole, so we can use the triangle. Okay, we want to find mass, so mole times molar mass. Or this one we can take from the RAM. So what is the mass of zinc sulfate? It is number of mole times molar mass is given to you, 161. Alright, so the answer is 1.61. Don't forget to write gram. Alright, next question. Any more questions or not? That's all. Okay, thank you.